Well, hello and welcome everyone to our first Data 3 and Cisco Ask the Expert session. Today we are going to be covering all things Cisco DNA as far as automation goes. So I'm going to be presenting with Adam Radford. My name is Chris Day. And just a quick overview about us. I've been with Data 3 for 10 years. I'm a CCI here, the first SDA certified proof of value engineer in the ANZ region. I've also been certified to deliver DNA accelerators on behalf of Cisco, and that is one-on-one coaching through a customer success program that Cisco and Data 3 co-provide. I've also been working with Adam Radford for a number of years on a DNA initiative, helping getting out to market and increasing our own knowledge within Data 3 on the product line and helping our customers. And I'll pass it over to Adam to quickly give a brief over on himself.
Thanks, Chris, and thanks for attending, everybody. Really appreciate you taking the time. And thanks, Chris. It's been great working with you over the last few years. It's been great learning from you and sharing as we've helped customers along this journey. I've been at Cisco for quite a long time. I just realized it's 22 years now in a variety of roles. Before I worked at Cisco, I was a customer running a large campus network. So my background is network operations. And a couple of years ago, I became a little bit frustrated with the state of network operations, so became very excited around what we were doing inside Cisco to try and simplify the way that we build, operate, and manage networks. Been working with DNA Center before it was a product. Been working with the engineering teams really closely over the last 5 years or so, and of course working with many customers as they've started on this journey. Part of my role is talking to people, which I really enjoy, webinars and things like Cisco Live. So I've been doing a lot of events at Cisco Live. Obviously, recently that's been curtailed and virtual, but still enjoy reaching out to customers and participating in events like this one. So a big thank you to Data 3 for putting this on. I think you're on mute, Chris.
Just saying thank you, Adam, for that. But what we're here today to discuss is automation. So throughout this session, this is a Ask the Expert session. So we're going to give you a few demonstrations, discuss some automation concepts and a little bit more around automation. But we also invite you to ask questions as we go through. And we will have moments where we'll stop for Q&A. Please raise your hand. We have a moderator that can unmute you and let us know that you have a question, and you can give your question that way. There's also a Q&A section within WebEx where you can post your questions. So we're going to start off with why automate your network. This whole session is based off of network automation. So when I think about reasons why I want to automate my network or why my customers should automate their network, it really comes down to standards and enforcement for me, taking away that human error, streamlining processes, making things quicker, easier, more efficient. So with that standards and enforcement, we take a look at the SWIM service with network automation. Now, SWIM is our software and image management piece that's covered by DNA Center. This is where we can actually go into the DNA Center and specify that our policy is that all of our kit is at a certain version. And I don't know how many of you could go into your network right now and say every single one of my switches, every single one of my routers are at a specific version that I require them to be, or do you even have that defined on what that should look like? And this is where DNA Center can come in and help you with that. Is we can define this, and then when we're doing things like plug and play or LAN automation, those policies are enforced. So as a piece of kit comes onto the network, we're able to enforce a standard as far as a software image goes. we're also able to enforce a standard for onboarding configuration. So how do these devices need to look? What standards are in place for a device when it first comes onto the network as far as the configuration goes? We also have the ability to standardize our day-in configuration tasks. So this may be, we have a standard on the way an access port should look. We have a standard on the way a trunk port, or we have a standard on how a port channel should look. And we can use templates within DNA Center to push out that standard. And now the configuration across everything is the same. And when we do that, we're really starting to take away the human error element of the configuration, and we're able to have a much more predictive network. The other thing that we get into with automation is visibility. So with the DNA Center, there's a slew of reporting within DNA Center, not only from the standpoint of going into the dashboard and seeing a real-time report, but also gathering reports on what the health of your network has been. Is a big help, and with that reporting comes our analytics and assurance. So getting a bit of information on what is actually happening on the network, real-time alerting, and guided troubleshooting. The other key component of visibility is that all this data from your network is collected in the DNA Center and is accessible through APIs. So we can write automation scripts, we can integrate with third-party devices that support API integrations, and we can integrate into the DNA Center and have access to this data for our own consumption. So with automation, you should really start to see an increase in productivity. Why? Because it's easier. I'm not going through and manually typing out commands on a switch when I deploy it. I'm using a GUI-driven interface. I'm using automation languages. So we decrease our time and effort when it comes to automation. And this is across automating the wireless portion of the network. It's also the wired portion of the network. So with DNA Center, we really hope to see more automation as we move forward. So one of the things I wanted to talk about today was plug and play. And I think a good place to start with plug and play is when to use it. What is the use case for plug and play? There's actually quite a few different use cases for plug and play. It could be replacing or doing a refresh of network kit. It could be adding network kit to my existing network. But when we're using plug and play, we're actually automating the provisioning of a device. And that automation is making sure that our software images and our base configuration is up to date. So when do we use plug and play? Like I said, a new piece of kit going onto the network, refreshing a piece of kit. And I know Adam has talked a bit in the past about DNA Center's ability to do RMA. So there's a bit in there too. If we need to actually replace a piece of equipment, how do we do that with the DNA Center? How is that automated? What can be plug and played? Well, a lot of things can be plug and played. Access points can be plug and played. We can easily bring up an access point at a site, and DNA Center can orchestrate what controller does that AP need to connect to, and what RF profile should that AP receive based off of its location within our hierarchy. Where we put that AP could determine all sorts of configuration elements that the access point goes through. So DNA Center is great for large-scale wireless environments where we may have multiple controllers and we need to orchestrate what controllers those access points are going to. Routers can be plug and played. Switches, definitely plug and played. And Adam, I don't know if there's anything else that you can think of being plug and played, but I know there's some virtual components as well.
Yeah, and one of the things we've just added, Chris, is the 9800 controllers. So the WLCs can now be plug and played as well, which is a relatively new capability that we've added in.
So when we talk about plug and play, there's obviously going to be some requirements around plug and play. Now, a question I get asked a lot, and I might interact with you a bit, Adam, is around the licensing.
Yep.
What licensing do I require to actually plug and play my equipment?
Yeah, so plug and play is part of Essentials, so it's a core capability. So that's one of the nice things about it is that it's a base capability in terms of DNA Center and very easy to use in terms of licensing.
Now, as far as licensing requirements go, there's also some network requirements. And I'm going to talk a bit about a blog that Adam has been working on for a number of years and how he's developed that blog. He does discuss the 3 different methods of using plug and play. So the network, based off of how we're going to plug and play, needs to be set up to support plug and play. We have the DNS method where we can have the switches come up and look for DNS, but that drives some requirements around how we deploy our certificates with the DNA center and how we utilize the DNA center with DNS. We also have using DHCP to plug and play. So using the DHCP options to drive the equipment to where to go to register for plug and play. There is also the smart licensing component or the SmartNet component where the devices can go out to SmartNet, and that has the configuration of the DNA center, where the DNA center is, and tells the device how to communicate with the DNA center. And the great thing about Adam's blog is he kind of lays these out nicely so that you can make an informed decision on what method you want to use for plug and play. I normally go down the DHCP option path. It's very easy to do, and it has probably the least amount of requirements. But based off your use case, there might be a different reason why you would want to look at one of the other options for plug and play. And just it's good to know that there are quite a few options when it does come to plug and playing our devices. So with that comes the supporting services. So of course, if we're using the DNS methodology, we need DNS configured properly. If we're using the DHCP method, there needs to be DHCP scopes set up correctly to properly plug and play your devices. Now, one of the things that you'll see, and I get asked a bunch, is what I want for my DHCP service and what I want for my actual management of the networking equipment might be 2 separate things. That's one of the things that we show in the demonstration, is that you can plug and play in one network and then manage in a completely different network, the way the plug and play process works. So that's more of the supporting services, is making sure the DHCP scopes are set up properly, making sure that the network equipment that we're plugging into upstream is set up properly. Something that we can definitely assist with and that we look at when we go do these deployments. So I'd just like to know real quick, just talking about plug and play, a bit of the use cases and a bit of the requirements, if anyone has any further questions around plug and play just from this standpoint. And I'm just going to check. So I did get a question on, for PnP usage of DNS and DHCP, is there a requirement for Cisco, or can we use existing Microsoft services?
Yeah, so I guess, Chris, the answer to this is that it's standards-based options.
Yep.
So we don't care what the DHCP server is. And obviously, although when you're using the DNS method, DNS is the method of configuring the DNA center, you obviously still need to give the device an IP address. So you still need some base DHCP connectivity. It's just that you're providing a domain name in that scope instead of an option 43 string. So just about any DHCP server will support those options. They're configured in slightly different ways, but there is absolutely no dependency on the DNS or DHCP service in order to do plug and play.
Very good. One of the reasons I like DHCP over DNS is when we have a really large environment where we might have multiple DNA center clusters.
Yep.
We can use that option 43 to point to different clusters in different networks.
Yep. And I think you made a great point. It really does depend. That's why we provide the two different options, and have a conversation with us around which one's best for you.
So what I would like to do is go through a demonstration of plug and play for everybody. And I'm pulling this directly from Adam's blog. There is a process to doing plug and play. And when we think about plug and play is deployed in layers. And it's very important that it's deployed in layers because the way that DNA Center deploys these layers ensures that the device is always reachable, always have communication, and that when it is time to secure that communications, that it is secured properly. So the actual configuration element, putting the configuration on the device is done in a secure method, so we're not sending clear text data across that pipe. So when we take a look at plug and play, we have creating our day 0 template. So this is our base configuration that we'll configure. The next step is our network profiles. So our network profiles are going to allow me to tie together my configuration with where in my hierarchy this device is going to be put, which is what location I'm going to put this device at. Based off the location, I want to use a specific base configuration. And then we have the actual claim of the devices. So I'll just kind of walk through a bit of where we see the templates built. So I have here our DNA Center Data 3. I will log in a bit slower so that I don't put in the wrong password.
That means this is a live demo, Chris. It's not pre-canned.
It is.
And just while you're logging in, Chris, I think
Yep.
the other point that's interesting to mention is that as we've moved towards providing plug and play consistently across wired, wireless and routing, there has been some things that we've done in the switching space in particular to make it much, much simpler in those sort of more sophisticated switching deployments. So auto detecting trunks, auto detecting ether channels, auto detecting native VLANs, all of those sorts of things have become part of the plug and play process and embedded in iOS to make sure that that just happens as it should.
Yep. So what I'll do here is first we're going to take a look at a day 0 template, and I'm just going to go over some, I wouldn't say it's best practices, but it's practices that I follow when I'm doing plug and play. So coming into my tools, I have my template editor. Now I'm putting all my onboarding configuration, that day 0 configuration is going under this onboarding configuration project. So consider these different projects that we have within the DNA Center as far as templates go. I have a few onboarding templates here. I have this PMP switch template. Now there's a couple different languages that we can use to write our templates. I'm using Velocity, which is the exact same language that we use in Prime. The great thing about this is that if you have templates in Prime, you can copy and paste them over to the DNA Center. Now, Adam, this is something I'm not sure of. Has there been any development on actually streamlining the process of getting templates from Prime into DNA Center, or is that still a copy and paste operation?
Yeah, so there is work going on there. One of the initiatives that we have in place at the moment is helping people migrate from Prime to DNA Center. And part of that is a migration tool that is going to take, or does take data from Prime and put it into DNA Center, and templates are obviously a part of that.
One thing you'll notice about the configuration here is there's not a lot of configuration in here. But when I get done doing the plug and play, there's going to be a lot more configuration than what you see. And the reason why that is there's a mixture of what we called intent configuration and templated configuration. So what I'm careful about doing when I build out my configuration templates is I don't duplicate what my intent is going to do. So what you will not see in here is NTP configuration. You won't see AAA configuration. You don't see credentials going in here. My credentials are securely passed through and configured on the device through the plug and play workflow. So I don't need to worry about that with my day zero template. I also don't require a host name if I don't want to, but I do like having the host name in the template. So it's really up to you what you want to put in here. My main thing is to understand the intent that the DNA Center pushes and try not to duplicate that intent inside of your template configuration. Because there is an order of operation when it comes to deploying templates, and we don't want one to overwrite the other. So in here, you're going to see that we have, it looks like a basic switch configuration. And then I have these variables which have $signs on them. Now, we're not going to make this into a templating class, but one thing I do like to do is as I'm writing out these templates, I create a CSV file. And I'm just opening up that CSV file now. So if I bring the CSV file into view, what you see along the top is I have parameters. So these are all the parameters I'm going to list. So anytime that you see a $sign and a parameter, I'm going to put that in here. Now, if my parameter is a required parameter, I put a star next to it. And I can go into the template section and say what's required and what's not required. But by default, anytime I call upon a variable, that variable is going to be a requirement until I go tell the templating editor otherwise. Across the parameters, I'm going to be putting in all my serial numbers of the switches I want to plug and play. So as I get boxes, as I order kit, when those orders come through, the serial numbers are always included. So I can actually start populating this with serial numbers. And then I can define where I'm going to put those switches. And then I can start filling out my variables in here. And the good thing about this is going to be a running list of all the switches that I deploy with this template. And I can leave all this information. So I can leave these loopback addresses in here. And if I, in the future, use this exact CSV file to claim some more devices, anything that's already been claimed, it doesn't get looked at. It will only take a look at what serial number am I currently claiming, take a look at the CSV file, and then import the configuration data based off of that serial number. So I don't need to worry about getting errors because I have a serial number inside my CSV file that isn't actually being claimed. So it actually ends up being a good way to log what you have plug and played.
And presumably, Chris, you could put this under version control, you could put it into Git, and you could have your network as code or infrastructure as code as you manage those different versions.
Well, one thing that you bring up that's really good too, Adam, is this is something I can put next to my plug and play automation script. So a lot of what I'm about to show you is network automation, but it can be taken to another level. I could have a Python script calling out the DNA Center saying, do you have a device waiting to be claimed? And if it does, that script could utilize this data to fully automate the claiming of that device to the point where I don't even have to get an administrator involved in a device claim. So what we're showing you here, you can actually take it a step further, and having these CSV files really assist with that. So we can see this data here. Now the next part of plug and play is within DNA Center, you're going to want to have a hierarchy designed. So we have a network hierarchy here. So I have a production hierarchy, I have a national lab hierarchy, and we can see the different offices that we have within Data 3. All my network settings, this is what I call the intent configuration of the network. The first thing that's going to happen when we claim a device is that these device credentials are going to get pushed to that device. We're also going to do the software and image management piece of it. So the device is going to get upgraded or downgraded based off what your policy is. So I think that's all another thing to keep in mind is that if a product gets shipped from the warehouse and it is on a newer version than what you deem to be your golden image, that device will get downgraded. Go ahead, Adam.
The other implication of this page, Chris, is that because the credentials are going to be pushed out, in theory, you don't actually need a template. So you can plug and play a device with no configuration at all, but that device is still going to be managed and operated by DNA Center and fully contactable and fully managed by DNA Center because of that.
And I'm going to talk a bit more about that when we hit the LAN automation section, because that's one of my favorite parts about LAN automation is the ability to deploy a complete fabric without ever even touching the switch, ever logging into it. I can have a fully deployed network where people can log in, be fully authenticated, everything's automated without ever logging in or even pushing a template off of the switch. So under my networking components, this is where I lay out my AAA settings, DHCP settings, DNS settings, NTP settings, the time zone. So this can be changed at different levels of the hierarchy based off of what site I'm assigning the device to. We also have the ability to add a third-party image distribution. So if you don't want to distribute your image from the DNA Center, we could have an SFTP or an FTP source somewhere. We can also say, where do we want to send StealthWatch flows to? So if you have a StealthWatch server, and I'm not too sure if you could even use this to point net flows to a seam if you had a seam.
Yeah, it's just a redirection. So.
Yep. So once I have all this configured, our next step is to go into our network profiles and to create a profile that is assigned to a site. And then in that profile is where we say, what templates do we want to use for our day zero operation? Now I have in here 2 different templates that I could select from, and I'm going to show you how to select those. We may just want to have a single plug and play template. So I have multiples. Maybe I'm plug and playing different between a core switch, a distribution switch, and an access switch. So I can have those different templates in here if I want to and select which one I want to deploy. This is also where we attach any day in templates. So if I want to start pushing port configuration, things that I might do after an onboarding process, this is where I would attach those templates. So we've seen the day zero templates. We've seen the profiles and how to add the sites to the profiles. So the next thing I want to do is actually show you the plug and play process. So with the plug and play process, I have a network of 4 switches just taken out of the box and plugged in, never touched. No one's gone through the console, CLI'd in. All these are done is been plugged into the network and powered on. So just log into the DNA Center, going into my provisioning and the plug and play task. We can see my devices have registered to the DNA Center. Now, the next thing I want to show you here is looking at our identity services, because we have a rich integration with ICE. We're going to see some things happen inside of ICE that would normally be a manual task. So as you can see in here, my switches that we're going to plug and play do not exist in ICE. So what we're going to go ahead and do is go back to the DNA Center and claim these 2 switches. Now, during the claim process, I'm going to assign these to a site or somewhere in the hierarchy. This page here, this is where I can go in and I can see what image is going to be deployed to the switches, and I can also see what template is going to be deployed to the switch. If this is not the template I want, I can come in, click that drop down, and select the template that I want that was assigned to the site. So this screen here what I've done is I've clicked on the PMP switch templates, the top of that list, and I'm going to go ahead and import my CSV file now. The same CSV file that I just showed you. We're going to click on that. We're going to import that, and then what you'll see is all the data that I want is going to be populated into those individual switches. So you can see how the host name changed, the loopback IP address changed. Once I'm good with that, I go ahead and claim these devices. So through that claim process, devices would have their images upgraded and all the configuration from the day zero template and the credentials have been pushed to that device. The next step is for those devices to register into inventory. Now, what you may not have noticed here is that the IP address that this register for plug and play and the IP address that we're actually using to manage it have completely changed. And this is because the device actually goes and does another registration with a defined interface to the DNA center. So as I said, this is done in layers. So since we've done the initial onboarding, now what I want to do is I want to push that network intent to the device, which is what I'm doing here. So this is kind of the second phase of claiming. What I'll point out in here is you can see what we're putting on the device. We're putting NTP information. We're putting in AAA settings, DHCP, all that stuff from the intent is what we're going to push to the device at this time.
And Chris, there's a question in the Q&A asking about brownfield deployment. And the answer to that question is if you just add the device to DNA Center, that's sort of like doing a plug and play. It's going to be in the inventory. It's not going to be provisioned. It's only when you go to provision the device, which is what Chris just did, that things like NTP, TACACS, and radius will be pushed. If a device already has an existing TACACS and radius config, we won't let you provision it because obviously there's a significant danger of you losing connectivity with the device. You don't have to have TACACS and radius, so you can choose to have them not used for a particular site.
Thanks, Adam. So moving on now, I'm about to provision the intent onto this device, and I have a few options in here. I have the option to provision this now. I'll have the option to actually schedule the provisioning if I want to schedule for after hours. And then there is a new task in here called Generate Configuration Preview. This is nice because I can have the configuration that's going to go onto the switch, I can have it generated so that I can go take a look at it before I actually deploy the config. So this is just showing the different options. So we'll go ahead and deploy this now. And then what I want to do is just switch my focus from inventory to provision. And I can see what state are we in the provisioning process. So I can see border 2 here, that switch is in the configuration process. Now, once those are complete, so I hit this refresh button and they're completed, I can now see that the FQDNs are populated on the switch. So that means that the intent pushed DNS settings to the switch. And this is a reflection of that switch now knowing what its FQDN is and its host name. So I can see that this intent has successfully been pushed to those switches. Now, the next thing I want to show you is what happened to ICE. So while this was all happening, if I hit my refresh button, I can see my 2 nodes, border 1 and border 2, have populated inside of ICE. And if I come into ICE, the node name is there, the IP address that I want to manage the device from is there. All the configuration for radius is there, including our pre-share key. If I did TACACS, TACACS configuration is there. SNMP configuration is there to help me with profiling. And then my TrustX settings are there. So we have actually created a pack file, pack key, and if I went to that device right now and took a look at it, that device would have all my environmental data from TrustX on it. and this is without me ever touching the device. You never saw anyone use a CLI or SSH into the device, and it is fully ready to go as far as TrustSec is concerned. So that's really the power of the plug and play session. So you just seen, and if you would have seen this in real time, from powering on the device to the time that device is fully ready to use, where I can log into it with my TACACS credentials, we're doing this in under 10 minutes. I think I timed it at about 6 minutes. Now, if there are updates to do in iOS, you got to wait for those updates to happen. But again, that's not something that you need to think about. This is a task that we're taking out of your hands. I don't need to think about, did I upgrade the iOS on the device? The plug and play process took care of that for you. So that's the demonstration of plug and play. I hope everyone got a bit out of that and can kind of see the value that we get with plug and play. Now, just need to come back to slide deck. So I just want to talk about resources when it comes to plug and play. Adam has a number of blogs. I would strongly suggest, if plug and play or actually anything DNA related is of interest to you, that you visit Adam's blog. So you can see it here, blogs.cisco.com/author/Adam Radford. Now, I just wanted to highlight some of his blog entries that I found to be very, very useful. So there's a using Velocity create plug and play templates. So if you want to learn a bit more about how to write the templates to do these onboarding configurations, I'd definitely look at that. So he's got part 1 through 4 of that. He also has the fundamentals of Cisco DNA Center plug and play day 0 networking. So putting a little bit more explanation on what I just talked about. And then if you want to get really fancy, there's a using advanced velocity templates in DNA Center. And Adam, is there any plans on writing one for
Ginger?
the other? Yeah,
yes.
Ginger.
Yes, there is. It's been on my to-do list, unfortunately, for longer than it should have been. I just need to finish it off. So there's a bunch that I have planned around Ginger, including the migration piece, so how you would migrate and change your templates from Velocity to Ginger if you chose.
Yep. Now, before we move on, are there any other questions regarding plug and play? Now, I might ask a question, Adam. We talked about making plug and play work better with switch stacks. What development have we done with switch stacks, and is there a best practice to follow when actually putting together a stack that's going to be plug and played?
Yeah, totally. So this is something that we learned from the APIC-EM days, from those of you who remember APIC-EM. One of the challenges with switch stacks is that the order that the stack members come up is non-deterministic. And the reason that that's important is that there's this concept of a member number, which is going to influence the name of an interface. So switch member number 1 will have interfaces gigabit 1/0/x. Switch member number 2 will be 2/0/x, etc. So that member number is the prefix of any interface name that you're going to need for configuration. Now, the reason that that's a problem is, particularly for uplinks, you're probably not going to have the same interface on all switches connected as an uplink. So it is important, and for an operational and management perspective, most people like to number their switches top to bottom or bottom to top, whatever it is. And we've added this capability called a switch renumber, which when you claim the device, you can specify the serial number of the top of rack switch. As long as you have the cabling scheme complete, so you need to have a full circle in terms of your stack cables. You can have it in either direction now. You just need to say which direction, because based on that, we can tell which switch is up, and then we can renumber all the subsequent switches.
Excellent. Okay, we did get another one. We've been asked, What are the backup processes like for our equipment?
Yep. So that's a great question. DNAC actually does that for you. The reason that we need to do that is for advanced capabilities like RMA or Return Manufacturer Authorization, where we can replace a switch with exactly the same switch and put the full config on. We need to be doing the backup. The one thing that we haven't done is expose those backup configs to you so that you can use them in ways that you might want to. It's available via an API now, but in the next 2 releases, we'll have a UI support for that so that you can actually have a look at those configs, get access to them through the GUI, as opposed to having to make a REST API call to grab those configurations.
No, I think that's good. I also think it's important to note too that if you do go take a look at configuration elements within DNA Center through the GUI, all the sensitive data has actually been encrypted.
Yeah, so that was a challenge because we've always had the config there, but it's been a sanitized version of the config. This new API actually gives you the unsanitized config because for a number of use cases, people want to have access to the unsanitized config so that they can manage that in the way that they would like. And that's the thing that we've added that is new.
Yeah, the APIs are very powerful within the DNA Center, and like a lot of what I showed you through even the claim process. And I think Adam even had something in a blog around automating the plug and play process.
Yep.
All right. So our next subject in automation is LAN automation, which is probably one of my favorites. The only issue really with LAN automation is understanding when, where, and why you want to use LAN automation. There's a couple different reasons why you would want to use it. So Greenfield is definitely a place where I would want to use LAN automation. If I'm going to be deploying many switches and I want to get those switches up quickly and also understand that my configuration is standardized, I want to do LAN automation, and I'm putting LAN automation into prep for software-defined access. So if I'm doing SDA, LAN automation is something I want to use to deploy that Greenfield type site. So that's a real good answer to the when we're going to be looking at doing SDA. Is definitely a great use case. Where is in a Greenfield site. The why is really to make my underlay, the way that my devices are configured, to put them to a best practice for SDA. So we're going with layer 3 links between all the switches. All the links are going to be layer 3 links. We're using a well-supported routing protocol within Cisco, and I believe Cisco is working on possibly expanding the protocols used within LAN automation, but we use ISIS right now, and it's not, if you understand OSPF, you're going to get ISIS quite easily, and in some aspects I think it's even easier than OSPF. So that's the when, where, and why on LAN automation. It's not really for brownfield deployments. You might be able to put it into some brownfield, but I wouldn't suggest it. It's really for those greenfield networks. It's really for networks where I do want to use SDA. If I had a greenfield and my plan was not to use SDA, I'd really have to think about if it fits. What are my use cases? Do I want layer 3 separation at all my access layers? Those questions have to be asked before you say, is this a path I want to go down when I'm not deploying SDA? If you are deploying SDA and it's greenfield 100%, you want to go with LAN automation. So with LAN automation, I just want to talk about the IP addressing pool. So within DNA Center, we'll provision what's called IP address pools, which is just IP address space that the DNA Center can work with. When I say working with it is I may provision a pool for my link. So if we're taking a look at the diagram here, all these devices have redundant links between each other. Now, when LAN automation is done, each one of these links, there's going to be an IP address assigned to these. And these are going to be, if I remember right, Adam, it's /31 addresses that get put on there. So DNA Center is going to take this 24-bit mask that I give it, and it's going to carve that up for me. It's going to utilize that subnet range to build out my layer 3 links. It's also going to utilize that to make my loopback 0 addresses assigned to all these different devices. And we need those loopback 0 addresses because those are the destinations for our VTEPs and for the ISIS protocol. So when I'm doing LAN automation, I'm also making sure that my seed device is configured to properly redistribute the ISIS in and out. But the main component here, what we need the rest of the network to know about when we talk about an underlay within SDA is it's the loopback address, because that's what we're going to talk to. That's what is going to communicate with ICE. That's what's going to communicate with the DNA centers, these loopback addresses. What's not important is those point-to-point addresses. And this is where a link overlapping IP pool comes into play. So what I can do with a link overlapping pool is I could create an IP pool that is a 24-bit mask or whatever size I decide. But as I go do LAN automation for these different sites, I will say I want to use this exact same pool to build out that point-to-point links. And then what I do is on my Fusion device or my routing device is I'm going to prune out those addresses so that they're not shared with the rest of the network. So those point-to-points are only within that autonomous system of this network and not being shared outside, where it's the actual loopback addresses that I want to be shared. So we put in what's called a main IP pool, which is where my loopbacks are going to come from. And then I do a link overlapping pool, which is where my point-to-points are going to come from. Now, if I don't choose a link overlapping pool, then everything is built out of that main IP pool. So that's also good to know. So let's see if we have any jobs relating to LAN automation. I know the use cases aren't great, but for anyone that is looking at greenfield deployments, definitely anyone who's looking at greenfield with SDA, this is something that you really want to utilize. Okay, very good. So since there's no Q&A, I'm going to give a quick demo on LAN automation. Now, again, if you remember when we took a look at our identity services engine, we only had those 2 switches have been added. So just going to back up a bit here. So starting off from my inventory, I'm going to go to my actions provision, and I have a LAN automation task here. So in here, it's going to ask me what site is my seed device at. So I'm going to choose a site hierarchy that my seed device is at. When I choose that, that location, it's going to give me a list of all the switches that are currently there. I have an option in here to choose a peer site. So if we take a look at that diagram that I had up earlier, I have the 2 border nodes are in place right now. And my network is connected redundantly into those 2 border nodes. So what I'm doing is I'm saying I have a primary C device, but these devices are also connected into this other device. The DNA Center allows me to put, if I may for some reason have that device listed underneath a different site, I can choose it. But in this case, it's the same site. So my primary site, my peer site are the same. And so for my peer device, I put in my second border node. Now I'm going to tell it what interfaces do I find to be important. So this is the interfaces that my plug and play or my LAN automation devices are going to come through. So I select those interfaces, and then those interfaces are going to get configured for the layer 3 uplinks, and they're also going to be the interfaces that listen for device registrations. So I'm now going to say what site, as I discover devices, as devices are discovered through LAN automation, where do I want them to go in the hierarchy? So in this case, I'm selecting the same location, but it could be a different location. The next step is selecting an IP pool. So I have an IP pool here for LAN automation that has been built specifically for LAN automation. I'm going to make this my main IP pool. If I had an overlapping IP pool, a pool that I'm going to deploy across many SDA sites, this is where I would choose that link overlapping pool. But I'm not going to do the link overlapping pool in this demo. The next part is I'm just going to choose an ISIS domain password. Now I have this matching the domain password in my seed device as well. Now something very, very simple is if I want to enable multicast in the underlay, I just select that checkbox. Multicast is now enabled. Now with the host name mapping, what I want to point out here is if I go ahead and say I want to do a prefix of edge-0, what's going to happen is as devices register up, they're going to get edge-01, edge-02, edge-03, edge-04. So I'm kind of automating that process of hostname mappings there. What I like to do, if I can bring up my other CSV file, I like CSV files. So what I have here is I have a CSV file where I put switch names and I've mapped those switch names to serial numbers. So I can go ahead during the LAN automation process, I can import these serial numbers, I can import the CSV file in, and that's going to allow me to have a little bit more control over what switch gets what name. And that might be important. I may have a specific serial number I know has gone into this rack and I want it named appropriately. So we'll go ahead and get rid of that host name mapping there, and I will just select that CSV file. And then I start the automation process. So what we can do is we can take a look at where we're at in the automation process at any time by going to Actions, Provision, and the Status. So in the Status window, you can see that we're provisioning our seed device. So there's configuration that goes on that seed device to tell it how to tell these devices that have just been booted up for the first time how to register to the DNA center. So what I'll see under plug and play is I end up seeing all the devices that sit behind my seed device will just start listing in here. It's important that you don't jump the gun and go and try claiming these devices. Everything is going to happen on its own. There's no reason to claim, even though they're showing up in here. So what you'll see is they just start getting configured here. So we have IP addresses on there. I can see where we're at in the process. You can see the onboarding progress going. The devices finally finish and they end up in my inventory. Now, when you come into inventory, you may see the device show up as NA. You may see the device show up with an inventory sync aborted. I just don't worry about that. It's going to end up fixing itself. If you don't want to wait for that error to fix itself, you can always do a resync from the DNA center. But this is usually a very quick process. So what you'll see is I'll just go and hit the refresh button and that device will go green. So it's just if you're a bit quick, you'll see that error. Don't worry about those errors. So coming into provisioning status after that's happened, while the LAN automation status says that we're in progress, the reason why it says that we're in progress is because it doesn't know how many devices that we actually want to claim during this process. So it's important that if I'm going to LAN automate 20 devices, that I watch this and see when I have those 20 switches completed. Because I need to stop the LAN automation process at that time so that we can actually go in and get those layer 3 links configured. So I can see I have 2 devices completed, which is exactly the number that I'm expecting. We can see them completed in here for the devices. So this is the list of all the devices. And so what I want to do is click that stop button. And the stop button is going to go, it's going to clean up all the configuration on the seed device. And then it's going to go out and it's going to create the layer 3 links between all the devices. So I can see it's completed here. I can go take a look at the logs, and I can see that the LAN automation process has been completed. And you can see, you can go take a look at those logs and see what all the steps of the LAN automation process was. So now that LAN automation has completed, I want to go ahead and provision my intent, just like I did with plug and play. So we'll select our devices, and we'll go to provision, and we will provision these devices. So in here, you'll notice I don't select anything. I'm not selecting a template. I'm not filling out any variables, and it's just sending off all my AAA, DHCP, and DNS data. We'll go ahead and apply the provisioning data now. And then within a few seconds, they'll start out and start the configuration of these devices. And then I'll notice that the FQDN pops in from the DNS configuration that happened. I'll go into my Identity Services engine, hit my refresh, and I can see my 2 edge nodes are now inside of ICE. The only thing I need to do is change my location or device type based on the requirements for my policies. So my policy looks for anything that has fabric role on it, device type fabric. All I need to do is select that, and this switch will now work with my SDA fabric policies that I have configured inside of ICE. So a great thing to know in here, TrustSec, everything is completed within ICE. From a LAN automation standpoint and deploying SDA, I will never have to actually log into that device to have it fully functioning and working as an access endpoint. So that was a demonstration of LAN automation. Now, what I need to do now is, let Adam talk for a bit. Sorry, let me go back. So, Adam, I'll get our administrator to pass the ball over to you so you can run us through a bit of Wi-Fi automation.
Awesome. Thanks, Chris. So you should be able to see my screen around now. So I just want to talk a little bit about wireless automation. And really the point that we're trying to get to here is we're trying to get away from manual configuration of CLI on wireless LAN controllers. So one of the big objectives of wireless automation was to abstract that configuration into this concept of profiles and make it simpler and easier to deploy wireless, and particularly wireless in a consistent way. So going back to the themes that Chris was mentioning around why automation is important. One of the other things that we have been working on is, given the broad set of features and knobs and things that you can configure on DNA Center, we wanted to provide a way where, yes, it's easy to do the basic stuff, but then you can add on the specialist stuff, the tweaks, the optimizations that engineers like to do, but do it in a slightly different way. And this has been a little bit of a journey. We've started off with sort of the 80% use case, and then over time, we've been adding more and more features, more and more things that can be configured to make the coverage complete. And some of the implications of this are that you're looking at something like application experience, which is the ability to understand the performance of applications through the wireless network. So looking at latency loss and jitter. Something like that can be very simply deployed. It really just comes down to the click of a mouse to enable a service like application experience on a 9800 controller, for example. For those of you who know me, I'm not a massive fan of PowerPoint. I think a demonstration probably makes life a little bit easier. And what I wanted to do is just sort of step you through the fundamental concepts in terms of wireless automation inside DNA Center. Now we will come back to plug and play, but what I wanted to do was to set the stage around how the configuration works, because once you've got the configuration piece set, then the plug and play piece is trivial. Essentially all you're doing with plug and play is you're assigning an AP to a location, because then the location is mapped to a profile, the profile contains all of the configuration, and magic happens. So let's just take a look at what the constructs are, and that will give you a much better understanding of how this works. The other thing I will do is point out some of the enhancements that have happened. What I'm showing you is the 2.2.2 release, which is just FCS'd and will be generally available in the next week or two. So any of you who are running DNA Center already will have access to this very soon. So the first concept is you define things like wireless SSIDs. When you do that, you decide whether it's an enterprise or a guest, you define the security, you also get to see the wireless profiles that this is being used by, but essentially this is just defining the SSID itself. Now, one of the things that has changed in 2.2.2 is the ability to configure AAA on a per site basis. Now, I know there's a number of customers that have been asking for this. Yes, you can have a global AAA setting. In this case, I'm pointing to my ISE service, but now in 2.2.2, I can actually specify that AAA on a per site basis for an SSID. So that's something that is new that people have been asking for quite a long time. So if you go into one of these and edit it, basically you can change some basic capabilities around the security and the configuration of the SSID. The other thing that you need is you need to map an SSID to an interface, so you can define your interfaces here. Something that is new in 2.2.2 is the ability to define a VLAN group. So now in 2.2.2, you can actually take a set of these wireless interfaces and map them to a VLAN group, which again is something that people have been asking for, particularly for sort of larger scale wireless networks. You also have the ability to define radio frequency profiles. So these are the channels, the data rates, channel widths, etc. that you use. You can define these based on an existing profile. You can inherit from a profile and then make changes, but it gives you pretty fine-grained control over the RF characteristics for the radios. Now, the reason that this is important is that we've separated out the concept of the SSID to the RF environment that the access point is operating in. So technically, I kind of glossed over the fact that when you plug and play an AP, yes, you assign it to a site that gives you the SSID, etc. The other thing that you do is you give the radio an RF profile, which defines the RF characteristics for that particular radio, and they can be consistent across sites or vary in between sites. So this is just some basic setup in terms of the profiles, etc., and just defining those basic concepts. You've also got integration into CMX or DNA spaces. Again, in 2.2.2, there is native integration into DNA spaces. It was available in 2.1.2 as a special package. It is now native. So I can just natively integrate into DNA spaces, and pretty much it's one click and I'm done. Things like Flex Connect, native VLANs can be prescribed, and then there's a bunch of other settings that I can do that I won't go through here. So once you've got these basic concepts around the SSIDs and the RF profiles, interfaces, you then tie those together in what's called a wireless profile. So Chris showed you a wired profile for plug and play. This is pretty much the same thing. You define the profile, you map it to a series of sites, up to you which sites you map it to. And let me just move my video out of the way. And then if you look at how you configure this, essentially what the profile is a set of SSIDs. So I add the SSID, I decide whether it's fabric or not, if it's SDA. I can then define the interface or the VLAN group that it gets mapped to in this particular site. I can decide if it's Flex Connect or not. And that's pretty much all I need to do. So that gives me a list of SSIDs that are going to be available in this site and the interfaces that they map to. Now, in terms of the extra configuration, I have two ways of doing that. I can define something called model config, and I'll talk about that in a sec. That is, all of the other micro settings that you might want to apply. I can also use a template, which is just a standard CLI template. If I want to, we're trying to move away from that to make it as simple and as abstract as possible. And there are also some advanced settings around things like AP groups and site tags and those mappings that I can define and import if I want to, because by default, DNAC is going to generate those itself. If you want to have a prescriptive list, you can define your own. So going into the model-based configuration, I said that at the high level, it doesn't look like you're configuring that much. And there's this trade-off between how simple it is to configure versus how much detail you want to provide. And we have customers that want both. We have customers that want the simplest and easiest deployment or configuration of wireless. And we have some customers that want very sophisticated control of how their wireless is configured. So using the model-based configuration editor, we're trying to give you the best of both worlds. Again, you're not going to see any CLI. And the advantage of that, particularly given the transition that we're seeing from the traditional WLCs to 9800s, is it doesn't matter whether you're going to hit a 9800 or a WLC running Eros. All you're doing is you're defining models, and then they get rendered into the appropriate configuration for the appropriate target at the configuration time. So an example of advanced SSID configuration is here. I can define my own if I want to. I can use an existing one. And then I've got access to a whole bunch of attributes around things like peer-to-peer blocking, whether I require the client to use DHCP or not, whether it's a specific DHCP server, whether I'm using FlexConnect authentication. There's a whole bunch of things that I can do here. I can even specify client data rates, downstream, upstream rates per second. And then there's a bunch of other attributes around SSID data rates that I can configure, or even some of the advanced 802.1ax, so 802.11ax settings that I can provide. So this is an example of a set. Obviously, there's another set around things like clean air. There's some specific ones around AX. There's some specific ones around DHCP, and then also multicast. So you'll see us add more and more of these over time, but we're probably about 90% coverage at the moment. But this gives you much finer grained control over the configuration. And remember that those model-based configurations get attached here. So I can attach these to the network profile for a series of sites, and that gives me my consistency. So once I've done that, I then need to provision my WLC. And when I provision my wireless LAN controller, all I need to do is go into provisioning, provision the device, and it's going to step me through the things that I need to do. The first thing is I need to define the site that the wireless LAN controller controls. Now, the reason that this is important is that although the wireless LAN controller itself is in a specific location, because when you provision a device, it always has a location, the wireless LAN controller needs to know the locations that it's responsible for. And the reason for that is that when I map an access point to a location, that's going to map that access point back to the WLC, and that's the mechanism by which the WLC is going to pick up all of the configuration that needs to push to that particular access point. It's going to know the SSIDs that are valid. It's going to know, AAA. It's going to know all of those model-based configuration settings that I had provided. It's going to know all of that information. So I can add to those sites. I can do or make changes to those if I want to. I can also select secondary managed sites. So this is an N+1 scenario. So I can have a primary and a secondary. That N+1 configuration can be set up as well. It's a slightly different configuration. We've actually separated this out. In the past, you used to configure N+1 inside this workflow, but we've actually added a separate workflow to do that. I can also configure things like rolling AP upgrades. So again, if I have N+1, then we are able to do a rolling AP upgrade where we will reboot a certain percentage of access points at any point in time, thereby giving you full coverage of the environment as separate number of access points reboot. The wireless LAN controller is going to decide which ones to reboot and when based on the coverage view that it has of the network. So that's a very intelligent way of doing a rolling upgrade through the network and making sure you're still providing coverage at the same point in time. I do get to configure interfaces, etc. So I can just step through this. I can add model-based configs if I want to. I can add templates, which is advanced configuration. And then I'll get to the summary and be able to push out that configuration if I need to. So very consistent in terms of the way that we would traditionally do provisioning of switches. Very similar workflow, optimized a little bit around the unique demands of wireless LAN controllers and the fact that it's not only responsible for itself, but it's also responsible for the access points that connect to it. Now, the implication of this is when I come into plug and play, and if I was to select an access point, all I need to do for that access point is just assign it to a site and give it an RF profile. And then whenever that access point comes up and contacts DNA Center, it will get redirected to the appropriate wireless LAN controller and get all of the configuration downloaded to it. So really tight and simple integration, but based on the fact that the configuration is done via those profiles and makes it very easy to do. If you do plug and play, you don't need to touch the APs at all. If it is a brownfield environment or you've got the access points connected to the WLC already, you can provision them. So I can go in and provision an access point. When I do that, essentially what I'm going to be doing is assigning it to a site, and then based on that site, it will get a different configuration. And I can just step through this. If I want to, I can change the RF profile if I want to, because that's really the only thing I need to do. But this is exactly the same thing as plug and play would do. It's just with plug and play, it all happens in one step the moment the device connects to the network. So the next thing I wanted to show you, and this is some feedback that we've had from customers, is what happens if I want to make day end changes in an ad hoc way. Sometimes people want to fail a set of access points across to a controller. Sometimes they want to change the names of APs. So how do you handle some of those tasks? Well, again, this is a new feature in 2.2.2. There's a workflow that we've added around making changes to an existing deployment. So if I come in, select a particular site, pick those APs, what I can now do is make a bunch of changes to these access points. So the simplest thing that I can do, and this is a common use case, is change the name. But if you have a look up here, I've got a bunch of other things I can do around changing the AP parameters. I can change the 802.11 AN, AC, AX parameters. I can configure, .11 BGN parameters. I can go through a whole heap of changes and have those pushed out to a single AP or a set of APs depending on the use case. So you can see here I can do things like change the admin status, change the LED status, change the AP mode, change the failover priority. There's a heap of things that I can do here, and even point it to a new controller if I wanted to, which is could be useful if I'm trying to simulate an HA event, for example. You can go down into tweaking power assignment, tweaking channel assignment, channel width. And the whole point here is that you shouldn't need to log into the WLC again. You can actually do all this from DNA Center. Similarly for BGN, and then I get a summary. And as Chris showed you before, you don't always trust us in terms of what we're going to push. You like to verify first. So it does give you the ability to take a look at the CLI preview. There won't be anything here because I didn't actually put anything in, but it would give me the CLI preview of what was going to happen before I actually pushed it out. So really simple, making the day in operation of this and the tweaking of those configuration parameters much simpler if you need to do that. One of the other things that you get out of doing this is that if I wanted to, I could configure something called application visibility, which would give me an understanding of what was happening on the wireless network. So you notice that the enable application telemetry setting is grayed out because I've already done it. But if I did do that, essentially what I would get is a view of all of the applications that were running across the wireless network. I get basic stuff around usage and how much of the traffic is going through. But you notice that I get this health score. And this health score is comprised of metrics around packet loss and jitter. So I'm able to see that my SSH traffic, for example, is pretty good. It has a health score of 9, whereas my database service traffic has a slightly lower health score of 7. And this is not an assurance session, so I'm not going to give you any more insight into this except to say that you can drill down, scroll down, get access to all of the clients. There's a whole lot of information you can get, but this is an example of a capability that is really simple to enable because you've been doing the configuration via DNA Center. So I just want to finish with a couple of other things that Chris wanted me to cover. So this is a whirlwind tour of the wireless provisioning piece. It's something that we've spent a lot of time on. I think it's something that has come a long way, particularly over the last 6 to 12 months as we've added things like the model-based configurations and some of the new features in 2.2.2 that give you finer-grained control over things like VLAN groups, etc., and more common configs that larger scale deployments would need. So I just want to shift gears a little bit and talk about another concept that we've launched called AI Endpoint Analytics. And there is a reason that I want to cover this. And the reason I want to cover this is it ties back to one of the points that Chris was making around policy and policy visibility. So Endpoint Analytics is taking telemetry data from the network. It's not just metadata around things like DHCP, OUI, etc., but it's actually looking at NetFlow data and looking at how that endpoint is behaving. And the reason that that's important is that if you opt into this, you can send that data to an AI service that is then going to build a model essentially clustering all of the devices that behave similarly together. So it's using AI in terms of clustering technology to develop these clusters. Now you'll get a recommendation that comes back and basically says that these 5 devices are all behaving the same way. Would you like to label them? And for example, if I went and bought a Bosch coffee machine and I had them on every floor, they might behave in a certain way. They'll talk to certain servers. They'll talk in certain ways. There'll be a certain amount of traffic that they will send. And based on that traffic, along with other metadata that we collect, we can group them together and label them as Bosch coffee machines. You can accept proposals that are crowdsourced from us. So if there was a new Bosch coffee machine came out, we would not only cluster it, but if it was then labeled correctly, we would send that down to you, and you could accept that so that automatically you would know that, yes, this cluster of devices was the same, but they were in fact Bosch coffee machines. The other thing that we've started to do is this notion of a trust score. And what this means is if that Bosch coffee machine started to change behavior, so maybe it started communicating to a command and control server that we didn't expect, we would lower the trust score and you would be able to see a deviation from normal behavior based on the model that we had generated and the fact that this endpoint is now behaving differently. So that's kind of cool in its own right. But where this becomes interesting is if you look at the concept of AI endpoint analytics, this has just changed. So it would normally show me that the endpoint analytics piece would show me that the communication between those different endpoint groups, different endpoint groups, I would be able to see communication from those Bosch coffee machines and who in fact they were communicating to. So the whole idea of this endpoint analytics service is that based on those groups that can be defined for the endpoints, I'm able to look at communications patterns and look at how they're communicating between each other, or more importantly, into existing TrustSec security group tags that I have. And I will get a matrix there. It will show me, for example, it would show me all of these labels. It would show me stealth watch groups. I've got the ability to get this data from Identity Services Engine, which was the endpoint groups. I can get the scalable groups or security group tags from ICE, and I can also get the stealth watch groups and see the communication flows between each of those. So it'll drill down into the port level and show me the traffic flows that are occurring between groups, between endpoints, and between the stealth watch groups. So that's something that is relatively new that we've just added in. And I think it's quite a powerful capability. You can see the way that this is set up. I've got my scalable groups coming from the SGTs. I've got the ICE profiles, which are the endpoint groups. So you can see I've got an Apple device that's been classified. I can skip down into that. It's talking to an unknown scalable group. But if I click into that, you can see all of the unique traffic flows that are occurring here: DHCP, DNS, POP, SMTP, etc. I can do things like search for a particular MAC address or even a IP address. It will show me all of the communication flows between anything that has 10.11.120 or a MAC address, who it's talking to. I've got the ability to generate reports as well. There's a heap of reporting data that I can generate based on these communication flows. So a really powerful thing. If you look at the templates that we have here for group communication summary, so looking at all of these communications and looking at the group pairs, so which pairs of groups are communicating, this is a really powerful capability. So Chris wanted me to talk a little bit about roadmap. I know we're sort of running a little bit low on time. I wanted to cover a couple of things at a high level in terms of roadmap. So the config management, config drift thing is something that we are working on. We've added the concept of compliance already, so I can see config compliance. And if you look here, you can see this is relatively new, where I've got this non-compliant device. I can look at my devices and understanding how compliant they are. And that's from a software image perspective, it's from a security advisory perspective, but it's also from a startup versus running config. So I can see if these were out of sync, if the startup versus run had changed. We are extending this into config drift, so looking at different versions of the config and being able to see the difference between last week and this week, what lines of configuration had changed. And as I mentioned, adding that you can get access to those configs via API today, but being able to then download those configs and see those configs from the UI is something that we're working on as well. One of the other pieces, and this is sort of ancillary to this, but ThousandEyes is now integrated into Catalyst 9000 switches. That can be run as a Docker container, and that can actually be deployed from DNAC itself. So there is a workflow around how you can do that. I can deploy a container on DNAC, and if I was to do that, I don't need Flash on those particular switches anymore. I can actually go and deploy a ThousandEyes container on a Catalyst 9K that's running 17.4 or later, and I don't need to have a dedicated SSD drive, so I can just run it. So that's something that is new, and DNAC will help with that. There's a fair bit more around APs and AP management. One of the things that is coming is the RLAN ports. So remote LAN ports on some of the access points that we have if you're using them in dorms, so the ability to configure those. We're adding mesh support, we're adding 3D maps. Those are coming in the next 3 months or so. And then the final thing I think that's interesting from a wireless perspective is looking at AAA and DHCP as a service. So today, when we look at AAA and DHCP in terms of user onboarding, we show you for a particular user. But I think there is also a requirement to think about that horizontally across the network. So how is DHCP performing? How is AAA performing across my network? And then the final thing that we are looking at is support for or legacy devices. So as we look to move people from Prime to DNA Center, we are looking to support the older Cisco devices, not the same level of functionality, but at least give you some visibility of those. And that will be extended to third party. So we can do third party today via SDK, but we're also looking at a similar framework where you will no longer need an SDK to manage or get visibility of third party devices. So that's a little bit further out, but that's something that we're working on as well. And one of the reasons for adding non-supported Cisco devices is that we are looking at a network refresh capability, which would allow you to migrate from a 3750 to a Cat 9K, much the same way that with RMA today, if you're going from the same model 9K to 9K, you can do that in a seamless workflow. We're looking to allow you to do older model switches to newer model switches as well. So Chris, that was probably a whirlwind tour of the roadmap. I know we're sort of running a little bit late on time, but hopefully that gives you a flavor of some of the things we're working on.
Yeah, we did go over a bit. I just love the conversation around Thousand Eyes and where that's going. Yep. I think one thing I would point out, and you can correct me if I'm wrong, Adam, is that the Thousand Eyes agent has a web capability in it, and for the web agent component of the switch agent, I believe the SG drive is the solid state drive is still required SSD, for that, but everything else works fine. Yeah.
Yep.
It's really good. Now, thank you for the roadmap. I know one of the questions that comes a lot is, how long can I continue to buy Prime? How much longer is it relevant for? And when is support ending from it? Is DNA the replacement for Prime? So it's a common question I get, and I was just wondering, what is your stance on that?
Yeah, so there's no end of support, end of life for Prime right now. We're starting a program to actively move Prime customers to DNA Center. There was an announcement at Cisco Live around a tool called PDART, which is a tool that you can run on Prime that will show you basically how easy it is going to be for you to move from Prime to DNA Center based on the devices you're managing, the things that you're using Prime for, and the reports that you're running. So it'll give you a matrix of, these are the things that you're doing that are supported, these are the things that are on the roadmap, and these are the things that are gaps potentially. We're looking to close as many of those gaps as we can. And we've got a tool, as I mentioned, to help with the migration process. So expect over the next 6 months or so, we'll start to accelerate that migration from Prime to DNA Center, but it doesn't mean that the Prime is going away right now.
I think we're going to have to wrap it up. If anyone wants to stay and ask any questions, feel free to do so. I'll stay on for another 5 minutes for anyone that has any questions that they want to have answered. I do appreciate everyone staying with us for so long. I know we went a bit over, but hopefully this was informative, and I definitely had a good time. And Adam, thank you so much for joining me today.
No, absolute pleasure, Chris. Really appreciate the opportunity, and thank you everybody for spending time with us.